what we're going to do is we're going to do an ANOVA hypothesis test. And we are presented with this. Why won't this go away? There you go. And we are presented with these details of information here where we have looked at 4 months of data to evaluate 3 regional salespeople, right? So this is salesperson A and salesperson B and salesperson C. This is, Amy and Bill and Carlos, whatever. And this is whatever, January, February, March, and April. And you want to take a look at these and you want to say, well, there are some months when stuff is low in sales and this guy was high here and, or whatever, but are they the same? Are they different? Is there something that one salesperson is doing that is a better technique than the others? Do I have to fire one and I've got to figure out if they're the same or if they're not the same? Any of these questions are a reason to do this particular deal. And we're going to follow our 10-step process for hypotheses, noting obviously that we are declaring alpha to be at 0.05. Now, because we're doing an ANOVA, right away we know that we're dealing with an F distribution. It's kind of a given, and so let's keep that in mind as we move forward. We will come back to, let me erase that right there. We will come back to this calculation in a second, but let's begin our 10-step process as we normally do. Step 1, hypothesis in plain English. Hypothesis is that I want to know if any sales person is different. And so this is the exact opposite, right? My null hypothesis is that any sales person is not different. We're not saying that they're all the same. We're saying that they're not different, and we'll have to go back to the beginning of hypothesis testing to get into the weeds on that particular statement, but there it is. Number 2, what statistic are we using? We're going to use mu, or mu sub 1, mu sub 2, and mu sub 3. I guess technically in this case it's mu sub A, mu sub B, mu sub C, but we'll stick with our numbers for the sake of our own consistency. Step 3 is going to be one tail or two tail. By definition, ANOVAs are all one tails. And so let's stop here for a second. When in doubt, draw it out. The our normal distribution looks like this, and then we could have a left tail or a right tail or whatever. Not the case for the F. Our F distribution starts here, it goes down, and it goes off forever. All of our F distributions are going to be one-sided, and our critical value goes here because the F distribution is by definition one-sided. So by definition, it's one tail. It's one tail, one tail, one tail, one tail. 4, we're going to do the hypotheses that we just did upstairs, but we're just going to do them now in math. So we do H sub 0, H sub 1. I always like doing H sub 1 first, and so if any one of these is different, then you can do something that looks like this, but more traditionally, and for simpler understanding, any mu is different from the others. Or better said, at least one mu is different. H sub z means that they're all the same. That's the exact opposite. That's what we're going to get into here in a minute. All right. You can tell that we're rolling kind of quickly here, and that's okay. We haven't done anything super exciting yet. Step 5 is alpha. That's been declared at 0.05 from the question. Step 6 is the statistic. By definition, ANOVAs are all F distributions, Fstat, F distributions. Okay, so that's going to be pretty much the same for almost all the ANOVA hypothesis tests. Más o menos, more or less. And then we get to step 7. And now we start with the good stuff. At step 7, we have to determine their critical value. Critical value. When we do critical value, you know, it's often a good time to go ahead and get a little bit more formal with our drawing. When in doubt, draw it out. So we have a distribution that looks kind of like this. This is just for the ANOVAs. And we have the area under the curve to the right is equal to 0.05. So we have some critical value here at 0.05. And we got to figure out what that critical value is, because whatever that is going to be our rejection line, right? Anything over here on the right, we're going to reject the null hypothesis, and everything over here on the left, we're going to fail to reject the null hypothesis. And so we have to ask the question, what is, if I can erase that little part right there, what is the critical value at which that is going to happen? And so we figured critical values from the table. We figure critical values from the table, and let me see if I can bring in a table to do exactly that. And through the magic of show business, which we are not in, but sort of, I guess we are, right? I mean, I guess in this modern day of online education, a lot of professors are doing this as a matter of normalcy, or some version of this. Anyway, so here we are, and in order to get our table, we've got to figure out our numerator degrees of freedom and our denominator degrees of freedom in order to get here, which means that we need our ANOVA table. Where is our ANOVA table? ANOVA table. So we've got to calculate our ANOVA table. All right, how do we do this? So we're kind of at a standstill. We don't really know what to do. I'm going to zoom back in on these guys, and we need to do some calculations here. The first thing I need to do is the summation of sales for 1, and so I add all of these up. That turns into 47.49, and this one is whatever. Then I have to divide by 4, but I don't because I have this weird summation. And you know what? I'm actually going to write it down. Pull out my textbook real quick. And I get something that looks like the summation of j equals 1 to k of n sub j over x bar j minus x bar bar, all of that squared, which is basically a variance. And then under here I have k minus 1, which is, wait a minute, this is the degrees of freedom for the numerator. Maybe we don't need to do our ANOVA table yet. This gets really weird. It gets really complicated. And if it was 1997, we would be doing this by hand. But it's not 1997. And while we can figure out the numerator and the denominator without having to do all of that relatively easily, what we're going to do is we're going to take this guy and we're going to plug and play over into Excel. Because we're going to do more applicative work than make you do all of the other stuff. That's not the best that we can do. So here is our Excel. I need to make sure that you can see the top of it. So here's our Excel table. You know what? Let me actually fix this a little bit. Let me make this smaller so that we're within the appropriate window here. How's that? Is that better? Yes. So here's my Excel, here's my sheet, and here's my 3 salespersons. And we can do exactly what we did before, right? We can sum up 1, 2, 3, and then we can copy and paste to the right, and we can keep going. And so this makes it a lot easier to make those calculations, but Microsoft knows that we're going to do this. And up here at the top of your Excel is a button called Data. When you click on Data on the right-hand side, you'll see Data Analysis. Now, if you don't have Data Analysis when you click this tab, don't worry about it. Go to File, and down at the bottom, you'll have Options. You hit Options, and down at the bottom, you'll have add-ins. We'll hit add-ins, and then this screen will pop up. I don't know that I can make this screen any smaller. I cannot. But down here at the bottom, maybe I can move the whole thing. I cannot. Down here at the bottom, you have Manage Excel Add-ins, and you'll hit Go. This one I can move over. And then this add-in window will pop up. You'll want to check the very first analysis tool pack. Do not check on the virtual basic, right? That changes things a little bit. You just need the first one, and you're going to hit OK. When you hit analysis tool pack and you hit OK, and you come back to data, this data analysis tab should magically show up. All right. If you've got a Mac, the instructions are a little bit different, but about the same. You'll have to find another video for that. So you click on data analysis, and look at that. Alphabetically, ANOVA single factor is what we want. Don't worry about the two-factor stuff yet. That's a little bit more advanced. Right now, we're just doing a very simple single-factor ANOVA. And we're going to hit OK. And then we have this little computing screen that says, hey, what's my input range? And my input range, making sure that you click on this guy, is going to be the range that has my data in it. Notice that I am grabbing the A, the B, and the C, and I'm telling the computer, hey, my labels are in the first row. The alpha is not going to bother us so much. Leave 0.05 for now, because that's what we're doing in this particular problem. You can actually leave that alone, even if you're doing a different alpha, but that's not what we're doing now. And then we hit OK. Boom. We get a new sheet over here that I'm going to call ANOVA. I'm going to call this first one data, so that we can tell the difference between what we're doing. And in this guy, we actually have a nice ANOVA table. Ta-da! I'm going to delete these two because they're not gonna help us so much. We'll use those. I'll show you how to use those later. But for now, we get our nice little fancy ANOVA table right here. Our degrees of freedom between the groups is 2. That's 3 salespeople minus 1, so that's great. Within groups is 9. That's 4. 4 times 3 is 12 minus 3 gives us 9. So I think that's right. I think that's how we calculate that. But let me go ahead and just grab the entire ANOVA table here. Control C, and I'm going to paste it back. I'm going to paste it right about there. Right about here. And so if you're working a problem and you don't have an ANOVA table, you can go to Excel and have one created and constructed. In the old days, we'd make you do this by hand, but that's not exactly the point of teaching I want you to work on hypothesis testing, not necessarily the handheld calculations of the ANOVAs. You should be able to figure out summations. They are important, but not exactly the point of this class. And so here we have our classic ANOVA table, where 2 plus 9 equals 11. 6.5 plus 3.5 equals 38. Sum of the squares, all of that works out. 6.5 divided by 2 equals that guy. 31.5 divided by 9 equals 3.5. And obviously F is equal to 3.25 divided by 3.5 equals 0.92. All right, what is my critical value? Well, this isn't even the critical value, right? We haven't calculated that yet. My critical value is going to be dependent on the numerator degrees of freedom and the denominator degrees of freedom, which is 2 and 9. Okay, let's go back to our critical value table. Numerator is 2 degrees of freedom, and my denominator, you can't see that, can you? Here, let me screw it up. And my denominator, here's my denominators on the left, numerators on the right, on the top, right? And my denominator is 9. So I'm going to come down to and over 9 until I get to 4.2565. This is my critical value You can't see that. This is my critical value at alpha equals 0.05, right? So if I go to my graph again, what is this critical value? Well, here's 4.25. It is my actual critical value. This guy goes here. The answer here is, this guy goes here. The critical value is 4.2565. 4.25 is fine for me, but you know, you do whatever the book tells you to do. A little coffee, yeah. All right, so that is number 7. Let's move on to number 8. Number 8 in our hypothesis testing program is the calculation of the statistic, right? And this is where we would do the summation of j equals 1 to k, but k is actually within 2, and then it gets complicated, and then you do the summation of the summation, and then you do the n plus 1, where this is the MST on top, and we have to do it all again, and this is the MSE on the bottom, and so on. But again, we've already run this. We've already run this in Excel, so we already have a table. Excel has run this calculation for us. I'm going to do this in yellow, and my F statistic, ooh, yellow's not good. I'm going to do this in blue. My F statistic has already been calculated, and my F statistic is 0.92. 0.92. And so that's one of the great things about knowing your computer programs in modern age. You know, those of us that use even, you know, more sophisticated statistical programs will have the ANOVA tables just kind of jump out. We know what we're looking for. What you guys have to really focus on is the hypothesis testing process, so that when you get to, you know, if and when you get to the more complicated tables, you know what they're saying. You have to do the legwork on this. So if my Fstat is 0.92? 0.92? Yeah, let's just go take a look. 0.92, yeah. Or 0.93, I suppose, if you round it up. 0.93. Well, this is 4, so I'm going to have 1, 2, 3, 4, and that one goes over there. 0.93 is here somewhere, right? And so it looks like step 9 is make a decision. Step 9 is fail to reject. Fail to reject. Step 10, should be doing this in white. Step 10 then is my conclusion. So let's go to our null hypotheses, which are over here. I fail to reject the null hypothesis, so I'm really not considering that one. I have to assume that at alpha equals 0.05, there is no difference between the sales people, and that's my conclusion. My conclusion is that there is no difference in this particular example.